Hello everyone, welcome to the guided notes section or guided notes video for homework 3, which is features of quadratic functions. So what I'm looking at is a front and back page that looks like this, where you're matching the graph with the description. So this is a homework assignment, but I'm just going to show you how to get started on a couple of these. So let's take number 1. Just make this bigger so it's a little bit easier to see and I have more room to write. I'm going to look at this and I'm going to say, okay, I know that because the leading coefficient is negative, that this is going to open down. I know that the vertex is going to be negative b over 2a. So I could do all of this algebraically in this tiny little space. I could also, which might be easier, is look at this and find the matching equation. So negative x squared plus 3x plus 4. When I do that, sorry about this, that it's a little bit sideways. Bet you, yep, here it is, negative 1, or problem 1. So when I blow this up, I'm looking at, well, that's hard to see, but I'm looking at a graph that opens down with a y-intercept at 4. I'm looking at roots at, that looks like 4 and negative 1, and a vertex of maybe 1.5 comma 6.75, but let's double check that. So it may be easier to see on your paper. But as we look at that graph and we match it with the information that we can find here, the vertex would be at negative 3 over 2 times negative 1, so the vertex would be at 3/2 or 1.5, which means that the 1.5 comma something, when we plug 1.5 into that function, I believe we'll get 6.75 as we saw on that graph. The axis of symmetry is going to be the vertical line x equals 1.5, or the x coordinate for the vertex. The solutions we could factor. We could factor out a negative, and we'll get x squared minus 3x minus 4. So I'm looking for two numbers that multiply to negative 4 and sum to 3. That would be, let's see, negative 4 and plus 1. So x minus 4, x plus 1. That means the solutions are where x equals negative 1 and where x equals 4. Again, that's where this function is going to equal 0. That's what makes these the solutions. And again, if you look at that picture on the previous page, I think that we said that the x-intercepts are in fact at negative 1 and 4. The y-intercept is given to you right here. That is 4. You could also write the point 0 comma 4. That would be perfectly fine. The domain for this parabola is all real numbers. And the range, because it opens down, I have a maximum, so the range is going to be all y values that are less than or equal to that highest point at the vertex 6.75. Okay, here's an example of how this is working. You don't necessarily have to do all of the algebra, but I want you to fill in all of these key details based on the graph and maybe a little bit of algebra and your knowledge of quadratics.